The warfighter of the future, innovating the customer experience in aerospace and defense. Meet the Run DXC team.
I'm Neil Jacade.
I'm Karthik Krishnan.
I'm Alexandra Paitis.
I'm Jeremy Rosenblatt.
I'm Grace Zhang.
Over the course of this presentation, we'll be giving an overview of our client, the project objectives, our methodology, our recommendations, which take the form of use cases, and the impact of the project on both the end user and the client. Our client was DXC Technology, a $21 billion consulting firm that was reestablished in 2017 from a compendium of companies. More specifically, the team worked with the Aerospace, Defense, and Manufacturing branch of DXC's Transformation Initiative to complete the project. The team's objectives for the project were to understand the major problems concerning pilot safety and lethality, to create use cases which tailor disruptive technologies to address these problems, and to recommend these solutions to DXC and determine their potential impact.
First, we identified problems through interviews we conducted. Then we prioritized problems and mapped to industry. Then we moved on to mapping disruptive technology to problems. And lastly, we evaluated disruptive technology-based solutions. Next, we're going to go into the interview methodology. In phase 1, we interviewed end users. We interviewed 4 end users and identified problems that pilots face, aka the use cases. In phase 2, we interviewed 4 subject matter experts and developed insights into disruptive technology and potential applications. Lastly, in phase 3, we interviewed 6 DXC clients and looked at the adoption of technological solutions in the industry as a whole.
Our first technology use case involved using 5G and edge computing to improve battlefield communication. Through our interviews, we uncovered the fact that effective air-to-ground communications is key to ensuring the safety of both pilots and ground troops in close air support situations. Therefore, any solution that we hope to develop to improve battlefield communication needed to meet 3 main requirements. First, communications needed to be quickly relayed between pilots, ground troops, and commanders. And new systems that we would develop needed to be interoperable with existing infrastructure in order to be easily adopted. Finally, novel solutions had to be able to accommodate high-speed aircraft. To improve battlefield communications, we proposed the following solution. Currently, there are battlefield air communication node aircraft within the U.S. military, which provide reconnaissance, surveillance, and other communication services on the battlefield. We proposed integrating 5G technologies into these aircraft so that they could relay signals from commanders on the ground and troops on the ground and to jet aircraft and pilots who are flying sorties. These intermediate speed aircraft would act as a leapfrog for the 5G signal so that they could reach the high-speed jets as well as troops on the ground. We're hoping that in the future, as 5G technology improves, that this system could have a range of up to 60 kilometers.
Now we're going to move on to our aerial threat assessment use case. The main issue associated with this use case is that information overload in the cockpit can inhibit the threat assessment capability of fighter pilots. And if we delve deeper into this, we can see that there's 3 parts that we want to focus on. 1, we want to focus on why it's necessary. 2, we want to focus on what benefits can be provided if a solution exists. And 3, how a potential solution would look like. So the first point is that it's necessary because dynamic cockpit environments necessitates that pilots are able to make quick responses to potential threats. So this includes identifying a target, identifying if that target is a threat in the first place, and then if so, what kind of threat it poses. Secondly, being able to accurately identify a potential threat assessment of a target would give an indication of the military capabilities of an adversary. And lastly, if a solution were to exist, as such the one that we're proposing, it would leverage AI and machine learning for pattern recognition using data from multiple sources, such as on and off-board sensors. So here we can kind of see what a solution to this problem would look like. So what we have is we have 5 sample data points, namely weapons envelope, signal classification, target speed, off-board systems, and onboard systems, and all the data from these sources will be compared in some kind of data comparison stage. So this could include processing the data, cleaning the data, merging the data together from different sources into one data pool that can be easily used for the ML-based classification. And then once that's ready, we'll be sending it on to the algorithm, which is the next stage. So this is where the machine learning actually takes place. And one example of this could be Bayesian networks. This was found through some preliminary research that we did, and we found some research articles and research projects that actually applied Bayesian networks to aerial threat assessment in different environments, which was really cool. Lastly, after going through the machine learning algorithm, the pilot will be provided with threat assessment results, which can indicate if the target is a threat in the first place, and if so, what kind of threat it poses, and then that will ultimately lead to the pilot's final decision on how to respond to that threat.
Our last use case is Pilot Decision Assist. The recent rise in technological developments have enabled improved collection and transfer of data and intelligence. While this may be beneficial in helping communicate useful flight information to pilots, this may also cause pilots to experience information overload, which can prevent effective aviation, navigation, and communication. 3 features we think will help mitigate these problems is an AI system with machine learning to recognize patterns in expected pilot responses. Also, if pilots do not match the expected reaction, the machine will provide an advisory or a recommendation. Third, if the pilot is incapable of completing the task, a warning will be sent out to the air traffic controllers. A little blurb about what artificial intelligence really is the ability of a computer or machine to work without being encoded with commands.
Our team proposed an AI system that incorporates learning machines that utilize unsupervised learning to recognize patterns in flight conditions and pilot reactions. The solution includes an accident-generating simulation system that collects flight, environment, aircraft health, and cockpit action data to generate realistic simulations of flights. The pilot reaction system reads in pilot background data, such as demographics and training, as well as physiological and eye tracking data from wearables. The information from both systems are fed into a pattern recognition learning machine that analyzes patterns in pilots' reactions during the simulated flights. These patterns are then fed into a recommendation learning machine to provide recommendations for pilots' expected reactions when they are in similar situations. Finally, from our interviews, we gather that many pilots are cautious of relying on technologies to make decisions, so we include a pilot stress evaluator that analyzes pilots' physiological data to only deliver recommendations when pilots are deemed incapable of making safe decisions on their own effectively and efficiently.
To understand the implementation timeline for our different use cases, we use the Department of Defense's technology readiness levels to assess the maturity of the different new technologies that would be used in our use cases. First is quantum computing. Quantum computing has the potential for massive impact, but it's in the research stage right now, and it may take many, many decades before it becomes mature enough to be used on the battlefield. Therefore, we gave it a level of 1 to 2 on a scale of 1 to 9. Next was artificial intelligence and machine learning. AI and ML are being used in a wide variety of industrial and military applications already, so it's nearly ready for use in the use cases we proposed. Therefore, we gave it a score of between 7 or 8. Finally, 5G communications are already being used in a consumer environment. However, it'll take several years before it can be validated for military use due to some national security concerns. Therefore, we give it a level of between a 5 or a 6.
While conducting our interviews with DXC's clients, we realized that there are numerous human factors within the aerospace and defense industries that may act as barriers to implementation of our use cases. Firstly, the culture of many large organizations are resistant to change, creating a challenge of overcoming older and more conservative cultures in order to encourage innovation and improvement of existing processes. In addition, in an industry-wide standpoint, there is a misalignment between the demand for technology and the rate of its development, where technology is developing at a slower rate due to additional barriers such as legal restrictions and high costs. Finally, companies must continually adapt to the changing technological landscape by retraining and familiarizing their employees with new technologies, since it is crucial for employees to trust the machines that they work with each day. As such, while working with DXC, our team's efforts have helped to firstly identify human factors that may delay innovation, which must be overcome to enable successful adoption of technologies. We have also highlighted the potential benefits of disruptive technologies that are currently gaining traction, which are not yet realized in the aerospace and defense industries, and further imagined prospective uses for them.
Finally, with the ability to overcome such barriers, our use cases offer promising impacts to fighter pilots and other stakeholders by improving pilots' safety and lethality. While designing solutions that positively impact DXC's clients and fighter pilots, our team also generated value directly for DXC by saving them the time and money equivalent to over 600 employee hours towards researching disruptive technologies and interviewing stakeholders. We then created a foundation for successful proposals that DXC can present to their clients by vetting the many potential use cases we initially designed after our interviews to our final 3, which were selected by analyzing interview data and researching technologies to find those that have the greatest chance for successful implementation while bringing the most value. Our use cases also act as a platform that will help connect DXC with future clients and open doors for numerous potential contracts. Finally, our recommended use cases will help to lower the risk for DXC's proposals and help them direct their resource allocation to high-impact areas. Thank you for taking the time to learn about our work with DXC. We would also like to thank all the end users, subject matter experts, and DXC clients that we interviewed, as well as the Quest faculty, our faculty advisor, Dr. Eagle, and our project champions, Shankar and Mora.